foot move in each one of these planes? In the transverse plane, for example, we have internal and external rotation, most of which is really soft tissue motion at the hip. In the frontal plane, we have inversion and eversion, but we call the positions varus and valgus. In the sagittal plane, we have two flexions, dorsiflexion and plantar flexion. Firstly, why is the top of the foot called the dorsum? The reason is, embryologically, the limb buds emerge with the top of the foot facing the back, so that as you develop, you rotate down, and what was facing the dorsum of the body is now on top. So coming towards you should be extension, which is too weird. So we have two flexions, dorsiflexion and plantar flexion. Bones of the foot: the calcaneus or heel bone, the talus, navicular, cuboid, three cuneiforms, the metatarsals, and phalanges. I'm going to divide the foot into two major columns, depending on which major rear foot bone they emerge from. Those bones coming off the talus make up the medial column, the first three metatarsals. Those bones coming off the calcaneus make up the lateral column, fourth and fifth metatarsals. Then we further divide the foot into rays. We like to say that the hallux, the first metatarsal, and medial cuneiform make up the first ray, and there are 5 rays of the foot. Now, how does weight normally pass through, or ideally pass through the foot? Ideally, we would heel strike on the lateral side, come up the lateral, across the metatarsals, and out the great toe. Unfortunately, most people don't pass weight through the foot in an ideal pattern. Most people heel strike a little more medial, come slightly lateral, and out toes 2 and 3, until they go get a standard foot orthotic. Then they pass weight out 4 and 5. Now, some of your joints are cardinal body plane joints. They work on one of the 3 body planes. For example, the knee is very close to a sagittal plane joint. What I want you to notice is that if you have an axial joint or a hinge joint, the axis of motion is going to be perpendicular to the plane of motion. A little corollary to that is that if you push along an axis of motion, you'll get no motion at the joint. Why? If you push along the axis of the knee, you're not going to get knee extension. The reason? Because torque is force times distance. And that distance is measured between the axis and the force. Pushing along the axis, there's 0 distance.